The National Electrical Code, or NEC, does not permit wire nut splices within service entrance or subpanels. These panels are critical distribution points for electrical power, and any connections within them must be highly reliable and secure. Wire nuts, while acceptable for general wiring in other areas, are not considered suitable for the high current, high reliability requirements of service entrance and subpanels. Firstly, it's important to understand the purpose of a service entrance panel. This panel is the primary point where electrical power enters a building from the utility company. It contains the main breaker, which disconnects all power to the building in case of an emergency or overload. Secondly, subpanels, also known as distribution panels, are secondary panels that receive power from the main service entrance panel and distribute it to various circuits within the building. These panels are used to isolate different areas or types of loads such as lighting, appliances, or HVAC systems. Because these panels are central to the electrical system's operation, the NEC mandates specific requirements for the types of connections allowed within them. These requirements aim to minimize the risk of loose connections, arcing, and overheating, all of which can lead to electrical fires or equipment damage. The NEC emphasizes the use of more robust and permanent connection methods within service entrance and subpanels. These methods include the use of mechanical connectors such as set screw connectors, compression connectors, and terminal blocks. These connectors provide a secure and reliable connection that is less likely to loosen over time due to vibration, temperature changes, or corrosion. Set screw connectors are commonly used for connecting conductors to breakers, ground bars, and neutral bars within the panel. These connectors use a screw to tighten the conductor against a metal plate, creating a secure mechanical and electrical connection. Compression connectors are another popular option, particularly for larger conductors. These connectors use a specialized tool to crimp the connector onto the conductor, creating a gas-tight seal that prevents corrosion and ensures a reliable connection. Terminal blocks are often used for connecting multiple conductors together in a neat and organized manner. These blocks provide a convenient way to distribute power to various circuits and make it easier to troubleshoot and maintain the electrical system. While wire nuts are not permitted within service entrance and subpanels, they are commonly used for general wiring in other areas of a building. For example, wire nuts are often used to connect conductors within electrical boxes for lighting fixtures, receptacles, and switches. However, even in these applications, it's important to use the correct size and type of wire nut for the conductors being connected and to ensure that the connection is made properly. Improperly installed wire nut connections can lead to loose connections, arcing, and overheating, just like in service entrance and subpanels. The NEC provides specific guidelines for the proper use of wire nuts, including the number and size of conductors that can be connected together and the required torque for tightening the connection. It's also important to inspect wire nut connections periodically to ensure that they are still secure and in good condition. If a wire nut connection is found to be loose or corroded, it should be replaced immediately. In summary, the NEC prohibits the use of wire nut splices within service entrance and subpanels due to the high current and high reliability requirements of these panels. Instead, the NEC mandates the use of more robust and permanent connection methods such as mechanical connectors, compression connectors, and terminal blocks. These connectors provide a secure and reliable connection that is less likely to loosen over time and reduce the risk of electrical fires or equipment damage. It's crucial to understand and comply with the NEC regulations to ensure the safety and reliability of electrical systems. If there is any doubt about the correct way to make an electrical connection, it's always best to consult with a qualified electrician. They can provide guidance on the appropriate connection methods and ensure that the electrical system is installed and maintained in accordance with the NEC. Furthermore, understanding the specific articles within the NEC that address these requirements is essential for electrical professionals. While the NEC doesn't explicitly state no wire nuts in panels, the restrictions arise from the implied requirements for secure, reliable connections capable of handling the expected fault currents and continuous loads. Firstly, consider NEC Article 110.3. It covers examination, identification, installation, and use of equipment. This article requires that all electrical equipment be installed and used in accordance with the instructions included in the listing or labeling. Wire nuts are listed for specific applications, conductor sizes, and environmental conditions. The listing doesn't generally include use in panels where they might be subjected to high temperatures, vibration, or physical stress. Secondly, NEC Article 312.8 pertains to switch and overcurrent device enclosures suitable for use as junction boxes. It permits conductors to be spliced or tapped within enclosures, provided the splices and taps do not fill the wiring space to more than 75% of the cross-sectional area of the space. While this allows for splices, it does not override the general requirement for secure and reliable connections. The concern is that wire nuts are more susceptible to loosening over time compared to other methods in the high-stress environment of a service panel. Thirdly, the NEC emphasizes the importance of proper torque on connections. Terminal blocks and mechanical connectors allow for precise torque application, ensuring a secure connection. Wire nuts rely on the installer's judgment, which can lead to variability and potentially loose connections. Furthermore, consider the long-term reliability of connections. Service panels are expected to last for decades. Connections made with wire nuts can degrade over time due to corrosion, vibration, and thermal cycling. Mechanical connectors, especially those that are properly torqued and protected from the environment, are more likely to maintain their integrity over the life of the installation. Finally, the NEC prioritizes safety. The use of wire nuts in service panels increases the risk of loose connections, which can lead to arcing and overheating. These conditions can cause electrical fires, damage equipment, and endanger lives. By requiring more robust connection methods, the NEC minimizes these risks. In practical terms, this means using compression lugs, split bolt connectors, or terminal blocks for all connections within service panels. These connectors are designed to withstand the rigors of the environment and maintain a secure connection over time. When making connections in a service panel, always use the appropriate tools and follow the manufacturer's instructions. Ensure that all connections are properly torqued and that the conductors are securely seated in the connectors. Inspect connections regularly to ensure that they remain tight and in good condition. Remember, electrical work can be dangerous. If you are not qualified to work on electrical systems, consult with a licensed electrician. They have the knowledge and experience to ensure that the electrical system is installed and maintained safely and in accordance with the NEC. The National Electrical Code serves as a comprehensive guideline for safe electrical installations. Adhering to its regulations, especially concerning connection methods within service entrance and subpanels, is paramount for preventing electrical hazards and ensuring long-term system reliability. The prohibition of wire nut splices in these critical areas stems from their susceptibility to loosening, corrosion, and inability to withstand the high-stress environment. By opting for robust alternatives like mechanical connectors, compression connectors, and terminal blocks, electrical professionals reinforce the integrity and safety of the electrical system. These connectors offer superior mechanical strength, resistance to vibration and thermal cycling, and facilitate precise torque application for secure connections. The NEC emphasizes the importance of using listed equipment, properly torqued connections, and continuous maintenance for optimal electrical performance. Compliance with these guidelines not only minimizes the risk of electrical fires and equipment damage but also safeguards lives. Always consult with a licensed electrician for any electrical work to guarantee adherence to the code and ensure the safety of the installation.